Ray Ross, you want to run with it? Teach us everything you know about scanning. Hopefully that would take more than 20 minutes. So teach us some of what you know about scanning.
Half hour that I have, that would be a concern.
Yeah.
I guess thanks everybody for joining here. The intention is to just give a broad overview of laser scanning, both in the field and in the office. The idea is to familiarize ourselves a little more so we can sell it to existing and new clients. You can maybe speak the lingo or have kind of a basis to know if a job comes in that it may benefit from scanning. So yeah, I'll just kick it off here. So I'll just be going through in sections and pausing for questions, just so nobody loses it, holding on to a question for 20, 25 minutes.
Sounds good, Ross. Ross, can you see when people put their hands up?
Yeah, I've got that on my third screen over on the side here, so.
Okay, great. All right.
Yeah. All right, so yeah, I thought we'd kick it off with the stable of scanners that we do have here at Challenger currently. We have a Leica ScanStation P40, a P20, a smaller one called the RTC 360, and we also have two BLK 360s. These are much smaller ones and much cheaper as well. Not really strictly intended for surveyors, but they can be useful in a lot of different ways. Another bit of equipment that we have is this iStar Fusion camera. That's used along with the P-Series scanners for imaging, and I'll discuss that in a little bit here. I'll be uploading this PowerPoint presentation on the drive somewhere. I'll provide the link, and you can follow a few links that are in here. There's a comparison table from Leica themselves, showing kind of differences between each of these. So you'll have a few numbers to compare and contrast there. So I'll kick it off with the P40. This is kind of the top of the line one that we have and close to the top of the line for terrestrial scanners that most people would be using. It's comparable to a total station. So it's got the same dual axis compensator that Leica total station does. And its horizontal and vertical angular accuracy is 8 seconds. Its ranging accuracy is about 3 mil at 50 meters. Depends on the angle and the type of surface, but that's the broad number that they provide. We can get a little better, 2 millimeters when we're picking up targets with it. It's got a target acquisition mode. So once again, very comparable to what you get from a total station. This machine's about $100,000 when you buy it brand new. Came out in, I think, 2015, they unveiled it. So relatively old, but it's still pretty close to the top of the stack. The only one that they sell that's more expensive than this one is a P50, and the difference is the range. So this one has a maximum range of 270 meters, and that's at a half speed setting. And then the normal one we'd use would be the 120 meter range setting, and that collects at 1 million points a second. The P50 does up to 1.1 kilometers, but at that point, you're going to be having kind of degraded accuracy due to the range that you're getting returns at. Very particular product. There's not a lot of things you'd want to pick up with a total station observation at 100 kilometer or 1 kilometer away either. So. Yeah, it's also got an onboard camera on it, so it can do full dome images. They're extremely high resolution HDR images. It's, I think, in the range of like 100 and some megapixels, but it also takes about 10 minutes per setup to collect this data. So if you're going to be doing that on a project that's going to be 150 scans, that's not really tenable. It can be if the client wants it, but it also makes it much more expensive. This one has a completely customizable scan resolution as well. So that's in the horizontal and vertical axes. You can change it by the millimeter to that one. So you can get it to the exact amount that you want, not just the presets that come with it. It's got a pretty wide temperature range. So the data sheet they provide says -20 to +50. These are different based on each unit. I don't think I've personally used this one below -20 here, but I'd imagine it can go below that. I have used the P20 in about -25, and it still works. No damage really to it strictly. If it's in danger, it's going to give you an error message, or just spin around and say it's calibrating. So you'll know, but if you've got a job coming up, that's something to consider. We can also come up with a few solutions as well. There's jackets that you can use to insulate it, as well as putting, hand warmer things in it. A few ways you can get around that, but broadly, it shouldn't be too much of an issue for us unless we're talking like, Whitehorse or somewhere up north in the dead of winter. They're quite large and cumbersome, 27 pounds or so. So lugging this thing around all day is kind of like doing a kettlebell workout. It gets you pretty tight at the end of it if you're not used to it, especially if you sit in a chair broadly like I do. So yeah, get me out there in the field for a day and I'll be a little bit tight and I'll complain, but that's kind of normal. Yeah, it's got a couple sensitivity settings too. Normally we're never going to use the higher one. It takes 3 to 4 times as long to collect the data. It basically spins around and collects data in the same point a few times and gets rid of any outliers more so than it does in the normal mode. I am using that right now to do a floor flatness for a polished warehouse slab scan right now. So it does have its uses, but most of the time we're always going to be using the normal setting since it's so much faster. Going down the line here, we have the P20. This one's kind of the middle of the stack one that came out in 2013. Same dual access compensator, same angular accuracy, and the ranging accuracy is also comparable. The range isn't as much, and the sensitivity you can adjust, and it only has fixed scan resolutions as well. So there are definitely some limitations on it, but it's still a very useful piece of equipment. You can do a lot of work with this thing. Same camera on board too, so 10 minutes per setup for that one. About half the speed of the P40 and a little more noise on edge data, but still quite useful. So this is that camera I'd mentioned earlier. It's called the iStar Fusion. It's a little bit older as well, came out in about 2014. So once you finish your scan, you take the scanner off the tribrac, and then you replace it with this iStar camera that's calibrated to that exact same distance as well. So the point of origin of the picture is going to be exactly the same as the scan, and it collects a 360-degree image. The time it takes depends on the lighting conditions that it'll sense and also some of the settings you give it. But normally, if you're outside in good lighting, it's going to take about 10 seconds to take a picture. And the other good portion of that is if you have another set of legs set up, you pick up the scanner, move it to the next point, tell it to start scanning again. And while it's doing that, you put this on top of the previous set of legs and get it to take a picture. So it doesn't really stop you in the field. That pretty much peels off that 10 minutes per scan setup. The battery can run down, and then you have to use external battery packs that are kind of cumbersome. But it's really not that bad to use overall. The other good news for it is that it's got a very high ISO rating, so it can work in very dark environments. If you crank that up, I've used it nearly pitch black before, and it actually does get an okay result. But of course, it's going to take minutes to collect that image as well. So something else to consider. It also doesn't have to be used for scanning. It produces a panoramic image, so we could just go around and snap a few with this thing if we wanted to on site. They aren't cheap either. These things are about $11,000, but I got this one on a deal from a vendor in the States. It's a fair bit older now, so it doesn't really make sense to be buying these brand new, but it just allows us to be much quicker with imaging on the P-Series scanners if we need to. So this is the latest scanner we picked up. This is the RTC 360. It came out in 2018, I think. Much smaller, much lighter, much easier to use. Leica is trying to sell this and successfully selling this to a number of other sectors now. So we're starting to find that a lot of the general contractors are having these. We know that Leadcore has one. I think PCL has one. Ellis Don has one. They don't have a lot of them, and they spread them across the country. So we still have got some jobs with them for it. But something to consider. We just had one come up where they said, yes, we'd like a scan, and then they'd cancel it because it sounds like they had a crew mobilizing out of Vancouver to take care of that. It does not have the same compensator that the P-Series have. It has an IMU that can correct tilt up to 3 minutes of tilt, or 5 minutes in the high tilt mode. The way that we get around this, and especially to have this to have good data that we can check to, is to relate it to something that is leveled. So total station observations, if we tie in targets that have been tied with total station, that levels the whole thing. Angular accuracy is less as well at 18 seconds, ranging too. Across the board, it's just not quite that super high level instrument, but that the P series is. But the speed and ease of use of it kind of make up for it. The other advantage is that it has an onboard camera system. So it takes 1 minute to take images at each setup. And when we import these into the computer, it will automatically apply those as well. So there's no time on the office side adding that in. It also only comes with 3 scan resolutions. So you have low, medium, and high. And low and medium have a range of 130 meters, and high is a range of 65 meters. Generally, that doesn't matter though, since the angular and distancing accuracy is lower on this thing. I'll generally filter out data that's more than 80 meters away, just so we don't have some of that extra noise or something that could be misinterpreted or interfere with the cloud-to-cloud links we form later. It does have a listed temperature range of -5 to +40. I've used it in -20, the one that we have. So we haven't quite run up against that. I think the only real issue we had was Jeff going from the inside of a warm building to -25 outside, and it threw an error for a second. So we just waited for a bit and turned it off, turned it back on again, and it worked. I've seen similar things across the board online. A lot of people say they've gone down to like -27 with these before. And we could also rig up some kind of jacket if need be. But yeah, that's something to consider if you've got a job coming up that's, you know, going to be -35. It won't definitely just work. It may require a little bit more effort to get it going. The other disadvantage of it is that you can't acquire targets on board. You can only passively scan them, meaning that you would set up a target, so either on a rod or on a mag mount or on a tripod or even a paper target taped to a wall. You want to be within a few meters. Generally, I'll stick to 2 to 3. The maximum distance is about 10 meters that you'll want to be using the high scan setting. Another thing to note is we almost never will use the high scan setting because the data that comes out is so dense close, and then the ranging isn't as good, so you don't want to use that data further out. And just the amount of data that comes out is huge, so it'll choke your computer, and you really don't get much advantage from that. Moving on to the smallest ones that we have, we've got 2 of these guys, BLK 360s. Small, light, tiny, portable, much cheaper. They're about $25,000. They do have an onboard camera with a light, which is good. If you're in a dark area, you don't have to worry about illuminating things. Low dynamic range image is about 1.5 minutes to collect. HDR is about 3 minutes. Even further down, much less angular accuracy and distance, a lot noisier data. It's got a different laser type, so the wavelength is different. We found this with Marshall out in Whitehorse. We did a job out there, and it was the inside of a bar, and the walls were painted a matte black. I've never seen anything like it before. It actually returned nothing for the wall, literally nothing. It was just a blank spot. So using this thing, that is definitely something to be aware of. Those really dark and matte surfaces like that, you won't get much return. No, it's only got a very low level IMU compensator inside, so the level isn't good. If you're relating to total station data, that will correct that, but that's another thing to keep in mind. Really intended for interior spaces. People, architects or smaller firms, I don't see a ton of use for these, other than cramming in small areas or being able to transport around. But for us, it doesn't really offer something that you could refer to as survey grade. It will work for interior spaces, but definitely not one that we want to use all the time for that type of function. If you guys have seen Matterport home walkthroughs, you'll see this all the time for Realty stuff. It can be integrated with that platform as well, but there's a monthly cost associated. If you have a client where it comes up, we can do it. But it's unlikely given that those Matterport cameras are much, much cheaper and they don't normally need highly accurate data. We can do warehouses and things with these for that. Matterports don't really work for that, but Yeah, I think that's the broad strokes of the BLK. There's a whole bunch of other kinds out there. The one you most commonly see is a Faro. Cheaper once again, but ranging isn't great. Accuracy isn't great. Another more common one is the Rigel, but that one's extremely expensive. There are advantages. Doesn't really have onboard imaging. Uh, depends on what you're looking for, but we've mostly stuck with the Leica things because we kind of got into that ecosystem to start with, and it mostly seems to be the best to work with for surveyors. There's a lot of other kinds too. Some of these handheld SLAM scanners, simultaneous localization and mapping, I think it stands for. It's an algorithm that ties together as you move. This is never going to be the same quality of data as the scanners that we have, a terrestrial scanner that doesn't move as you scan. But of course, you're going to see people sell it like it is. It depends on their use, right? If you're just looking for broad strokes, what does an area look like that's going to be accurate within a decimeter in a small area? It'll be fine. But yeah, we mostly stay out of that world. Then you get to the more expensive mobile scanners. These range from, $250,000 to $1 million, really next level stuff. These can be plugged onto anything and related to a base station. So you can put it on a truck, you can put it on a train, you can put it on a boat, or you can have that backpack one on the side. Very good, clean data out of it. Not the same as, of course, a terrestrial scanner, but if you want to cover a highway or something like that, it can be done. And that also has a lot of other very expensive software that you need to make it work as well. So that's kind of the next level for that. Normally, I think we'd be sticking away from this. We can subcontract that. I've looked into it in the past. It has to be a large area. Otherwise, it's not really worth their initial setup and mobilization fee. Even, a few kilometers of road, based on a quote I got a couple years ago, that's going to cost you about 10 grand or something like that. So yeah, generally outside of that world. So that's a quick rundown of all the machines that we have. Did anybody have any questions? I'll just pause for a moment. Feel free to hop in. Yes, Drew. Pick you from the class.
you were talking about the sensitivity settings there. Can you expand on that a bit more? Like when you mentioned you're using the high sensitivity for this polished concrete. Is that sort of what it's designed for, reflective surfaces?
Yeah, anything that's not going to give you a clean return back. I'll give you a quick example here, actually. Since we've been doing that warehouse scan, I can just open it up and bring it up here. One of those. So this is a scan from the same point, and you can see the distance that it shows there. It gets a little noisier by the time you get to the end of it. And this one here at higher sensitivity just cuts off because it's not getting a solid return. When it spins around, it's much slower because it's getting 2 to 3 more measurements per point and just checking to see if it gets the same return, the same intensity return back. And that's another thing to note is the colors you see here are the intensity of the return. So a dark red surface is not very reflective, and a blue surface is highly reflective. So as you can see, this floor tapers off a fair bit near the end. So yeah, there's very rare circumstances where I would use this, but this is a case where it definitely is useful.
Roger that. Yeah, I know it adds a bunch of time to the scanning setups.
Yeah.
When you
3 to 4 times per setup.
Yeah.
So you go from 3 minutes to 13. That can slow you down a fair bit. Mike?
Hey, Ross, thanks. This is great. I'm just curious, the manufacturer's specs on the Precision typically indicate, a perfect reflector at 30 to 50 meters, reflect a perfect range, 90 degrees. What's the impact of a less than perfect reflector at a really obtuse angle like you see with the floor scanning? How would that impact the precision of the measurement and the reliability?
So there's a lot of filtering that goes on both on board the scanner and when you import the data into the office, you can actually turn up filtering for that. What you'll see it mostly on is on edges. So if you have like a building corner or something like that, you're going to get a lot more spray off the edge if you have that turned down either on the scanner or on the import. Largely, it's going to filter out anything that is out to lunch. The data, especially on the P40, is very, very consistent. I'll go over later more reflective surfaces, so things like windows and mirrors. Those are something we need to watch out for, and we have to remove that data in the office, so we're not using it for cloud-to-cloud links. But the stations themselves, they do an excellent job filtering out anything that doesn't work. And normally we're going to have a lot of different setups as well. So we'll have a representation of that surface too. And that's part of our QA QC, is to take a slice of it and check each one of them and ensure that they match. There was a good article that I linked in the start here. I'll just back it up a little bit. So for the P40, there's a couple white papers from Leica investigating some of this and kind of going over their findings on a lot of it and what you have to consider. So that would be good reading if you want to dig further into it. And they have one for the tilt compensation as well. That answer your question, Mike?
Sort of. Thanks.
Anybody else? All right, I guess we'll move on. A little bit about field work here. So I'm not going to get too in depth. Yeah, really isn't rocket science, but just time on the tools. So if it's like using a new total station or anything like that, generally, if we're surveyors, we kind of know what we want to get out of it. But with a new tool, it's going to take time to figure out how to get what we want out of it. One thing a lot of people ask is, like, oh, what are you getting behind that? It's just what you see. So if you put your eyeball where the mirror is at the scanner location, that's all it's going to see. You're not going to get, there's no x-rays, there's no anything. It's just pure LiDAR. You're picking up whatever it sees. So in the past, scanning used to be a lot more difficult. I know you guys had the C10 and the scan station way back in the day that took orders of magnitude more time to go through a scan. So 5, 6, 10 times slower, even more than that in some cases. So it's a lot quicker than it used to be. And you're kind of seeing that with the workflows now too, where the cloud to cloud is becoming bigger and bigger because we can take a lot more scan locations. And these links are very robust. It's as long as you have good overlap and good geometry around you, it's very, very strong. But of course, we always want to have control. So we have something to check to. And also in the cases of the RTC that we know the data is leveled. And yeah, we have some degree of checking for this stuff. So there's a lot of ways that you can come up with control. Simplest way for some of the BLK or RTC scans or even P-series indoors is to just print off some targets, tape them on the walls, and you can pick them up reflectorlessly with a total station. I always ask for more control than less control. I'd rather have way too much. So we need a minimum of 3 points to locate something and then 4 to have a check. I prefer much, much more than that across a job. I can turn some of these handles on and off and see if some of those numbers depart. That tells me if some of the cloud links may be suspect or not as strong as they need to be. So it's nice to have as many constraints as possible. And given the instruments that we have, a lot of times for a site survey, we'll be using GPS. So RTK GPS, I'll ask our field crews to take 2 shots, about 20-second observations, reset your RTK link, and take another shot, average of 2, see what the number comes to. And if you get 20 to 30 across a site, then that is a very, very strong result. Combining with the cloud-to-cloud links, we can be very confident in what we have with that. Of course, you can use any number of things to complete your control network. And it all depends on what your final result would be. If you are intending to use this for some kind of monitoring, you'll want to be doing, a least squares adjusted total station network with precise level between all of the points. And keep in mind that any error in your control is going to stack on top of the error that's inherent in the scanner itself. So when we're talking about those ranging errors, I generally would say that we're not going to get into something repeatable under a centimeter. If we do our due diligence, we can confidently say that everything, if we went in back and did it again, it's going to be repeatable within 1 centimeter. Online, you're going to see a lot of people claim better than that. Of course, this thing can measure a bunch of points a millimeter apart. That doesn't mean that they're accurate and repeatable points like that. So it's the competition aspect of this, right? People say whatever they need to get a customer, but that's just the hard limit of it. You're stacking your scanner error on top of control error. So just something to be aware of. And the points that we use for these largely are these plates that you see here. Those are the same height offset as a standard Leica prism. So if you pop that off a tripod or a bipod or a mag mount or any of those things, it's going to be the exact same offset. So that's going to be the exact same point. It makes it easiest for us to use. Looking at them, you'd think they're cheap. They're not. Those are $475 a piece. So of course we ask that field guys be very cautious with them. You can scratch up and score up that plate. It's a very intentionally matte surface that responds well to the scanner. So we don't want to have them all scratched up and beat up. It'll happen over time, but we want to avoid that as much as possible since, you know, you're pretty much $500 a pop if you replace one of those tiny little guys. So with the P series, as I mentioned before, you can collect targets on board and give them a name, a height, a number. And this is the big advantage of the P series. So the range that you'll want to collect these can be out to, you know, 120 meters with the P40, about 80 for the P20. I advise generally less than that. 40 to 50 meters is about as far as I like to go with that, just because you're going to be degrading over that space for that measurement that you're getting to your scanner plate. So if you're going larger areas than that, we'd prefer to measure with different sensors. So tie to 4 points in a local area for the scan, and then get its absolute position either via total station or GPS or something along those lines. The P-Series scanners do have traverse and resection and all kinds of functionality on board. It does add a significant amount of time. Pretty much the only time we're going to use that is when it's critical to know a result on site, but that's going to be so rare. The amount of time that you add trying to get that done, we prefer to just bring it into the office and offload that data there. And we can do all our checks in our QA and QC and everything that we need to in the office much easier. And also office time isn't worth as much as field time either. So we prefer to keep the scanner moving when we can. The RTC 360 is a bit different in that regard, and the P series can be used this exact same way as well, just a different workflow. So the intention is you set up your scanner right beside a target, you pick it up passively, you want to make sure that it's leveled, it's in the right spot and everything before you do. And it's usually nice to have a good set of field notes for that too, so where our points are. When you're using the RTC 360, it integrates with an iPad. You don't strictly have to use the iPad, but that can act as a very good field note stand-in for that, because it does form links in between. And we'll go over the RTC in just a sec here for how that works. And in the office, we name, number those targets, etc. So yeah, it's important to, you know, have an idea of that with quality field notes. So the RTC 360 has a Viz system built in, and this lets it follow itself in 3D space. So it's a combination of a altimeter, a gyroscope, an IMU, and a series of cameras and GPS sensors. So if you move around while you're carrying this thing and you've got the iPad open, you can actually watch it trot around the area that you've scanned in already. And it can form basic links in between that to allow you to both review what you have on the iPad in a much lower resolution version. And it kind of skips a step in the office wherein we would be doing the alignment for each one of these. So you essentially get an entire bundle that you can import into Register 360 in the office, and have that big chunk ready to go for you to start doing more control application, checking your cloud links, and then applying more cloud links to ensure that it's all very tight. P-Series and BLK don't have that. You can integrate them with an iPad, but it's almost never worth the effort of fumbling around with an iPad in the field and lining things up. That can act as a stand-in for field notes, but it's so much easier just to make a sketch yourself and then put the points where your scanner is, what control you tied from each scan where you intend that. As I mentioned before, the cloud to cloud, that's much larger than it used to be. You're going to see this in every type of scanner. It's the way that we can cover a vast amount of ground now compared to how we used to. It's very strong with good overlap. The general guidance is about 40% of the same elements you want a good spread of geometry around too. So horizontal, vertical at a good angle spread around you. Trees and vegetation, no bueno. That just does not work. It just shows up as noise. It's not a repeatable surface. So if you're going to be anywhere amongst vegetation, you will need control points to tie, and probably a fair bit of them. Of course, with using the RTC or any one of them, you want to have a loop, some kind of closure, a lot like a traverse. And as I mentioned before, it's not just connecting scan station 1 to 2, 2 to 3, 3 to 4. You also connect 1 to 5, 1 to 4, 2 to 4. You form a very strong network like that combined along with the control, and we do that all in the office. Another thing to keep in mind is the area around. So these are IP54 rated. I've seen demos of people pouring water on them while they're running, and yeah, apparently they don't break. Of course, I wouldn't recommend it. I have used one in heavy rain before. Didn't cause an issue. It will keep working, but of course, if there's torrential downpour, I mean, it's probably not worth it to risk damaging something this expensive. If you scan in snow, very heavy snow, and you don't have the point filtering turned up, the sensitivity turned up in the P40, it's going to show kind of in a big cloud around you. You will get a lot of data around it, and it's not really going to impact the quality of that data, but you will have that cloud around each one that you will have to delete from the individual scan if you're going to use it for cloud to cloud, because that will completely mess with the algorithm. It'll yank it around when it's looking for surfaces to pull itself together. Another point to be aware of too, water, it reflects off water. So if there's a pool of water, it's just going to be a black spot. There's going to be nothing there. So if you're doing a topo, you'll definitely want to keep that in mind. If we're doing a site scan with the intention of having a topo model, you're going to need to collect those low spots via GPS, total station, any other kind of sensor, and then we'll add it in afterwards.
Corey has a question there, Ross.
Yes, Corey.
Less of a question, just more of a thing to say about like the cloud to cloud. I remember the one job I did out in CNRL, and it was 2 separate days, exact same area, but there was a few inches of snow that melted between the 2 days, and you said it was really, really throwing off the cloud to cloud algorithm because it was trying to match that same snow to the same snow. So that's another thing to keep in mind.
Very good point, Corey. Yep, absolutely. That was an interesting one. I think there were a lot of snow drifts and melting going on. So yeah, those surfaces changed, and every time you'd run that cloud algorithm, it was the largest area, flat area that it could see, so it would stick it together. And of course, that can be all remedied with control and other checks too, right? But yeah, definitely something to be aware of. In the office itself, I can delete that data, and that's how I fixed it. I got rid of the snow on both days. And yeah, that allowed it to fix to more solid surfaces around. And of course, with control points as well, we can correct that. But yeah, good old CNRL. That was the next one I was going to outline. I was just out there recently, and on all these plant sites, they always have steam running either to, vent off different facilities or to even keep catch basins clear. And we did one recently that was the worst I've ever seen. So it was that steam combined with the coker structure dumping hot material into a pool when it was -20. So every now and then you'd have a plume that just, you couldn't see a foot in front of you. And it was very, very difficult. Of course, on a lot of those sites, there's very little you can actually do to get around that. They're not going to stop the equipment for you, but it added a significant amount of time for us in the office to delete all of that steam water vapor. I've got a picture here of it. You can see here. So imagine that times 80. We can delete them in bundles in Register 360, but it's still a massive amount of effort. And there are even a number that were scan points that were basically inside of a plume of vapor that we couldn't use. It refracted everything behind it, and we had to toss them. That's the first time I've encountered it to that degree. You're always going to see, you know, steam coming out of like anything out there, and it's usually further out. I'll generally delete it so it doesn't impact cloud to cloud. But when you're in the cloud, it's a little worse. And yeah, that was a tough one. So that's also something to perhaps ask if you're kicking off a job on one of these plant site type things. As I mentioned before, windows and mirrors, if you're doing inside stuff, reflective surfaces like a window or a mirror, it's gonna reflect what's around you back onto the other side. So of course that'll impact the cloud algorithm, but it'll also make the data ugly too. So when we get the point cloud out of it, it's going to have reflected stuff on each side. So prior to registering this together, we do want to go through and delete some of that stuff. It can add a fair bit of time as well. So if you're in a mall or something like that, it can be really something to take account of, that amount of noise that's coming out the other side. That can be remedied in a couple of ways. I've heard of people papering up windows, putting talcum powder or scan spray on stuff, but the amount of effort involved, it's almost not worth it because you'll have to put it up, take it down. It's better to just go through and scan it yourself. Any questions there? Mike?
Yeah, thanks, Ross. This is very informative. Just quick question with regards to preparing proposals and estimating work. Do you have a list of questions to ask about a given site? Presuming that you haven't seen it.
That's
like,
a good idea.
For example, industrial sites.
Yeah, to send out broadly. Yeah, to send out broadly to other folks here, that is a very good idea to have kind of a checklist. I always ask a lot of questions and do my best to get pictures of site. And if there's something I'm concerned with, outline that. That's the biggest thing. If you're talking one of these industrial sites, we've run into this a number of times with CNRL Horizon, where they have a plant view. So it's basically a model of the plant. And what they give you, they say, okay, quote it based on this, and you say, all right. Then you get out there, and just recently, that same one Corey was mentioning, there's a whole set of pipe racks in a place where, you know, you didn't think there was. In that example I just gave as well, there was scaffolding up around the structure itself. So of course you want to ask those questions, and if they can't answer them, just kind of have that as you know, exclusion or just an addendum to your proposal. Additional time can be added for, you know, structures that are present that weren't accounted for, or any number of those things. So that is a good idea. I perhaps will create a checklist of things for different types of sites that you'd want to look out for and ask about. But yeah, great point there. Anybody else? Five minutes left, so I'll have to move quick here. Scan registration. So this is the office portion when we actually bring it in to tie all the data together. There are the two programs that we use. There's Cyclone Core. That's sort of the legacy one and still the more robust solution. And they have Cyclone Register 360. This is the one you'll see in sales pitches, either people trying to, you know, sell you a scanner. More particularly, they'd like to say, oh, it's just push button. It just works. It just works. That's not true. You have to put your hands on, and you have to review the data and ensure everything's correct. It isn't just a flip the switch solution like a lot of the sales pitches you'll say it is. Cyclone Core also has a lot of other functions in it from years past, that there's either modeling or other virtual surveyor functions or check functions, a ton of useful stuff. And it can also ingest data from any number of sensors, UAV data, anything. You can combine it and register it together. It's commonly used even for other scanners as well. Faro stuff, a lot of people prefer it to Ferrocene. Yeah, generally considered to be one of the strongest solutions out there. Register 360, as I mentioned before, yeah, Leica do say that they're intended to complement each other if you ask, but they won't tell you that when they're trying to sell you a scanner. Register 360 does have these scan reports. To me, I find no use in them. Everybody wants a number to check to, right? That's standard thing being a surveyor. Like, what was your closure? You know, did you get a closing check? This seems to be what they want to pass along to pacify that. It's not useful. The strength that it shows there is error in averaged out between a lot of the links in the scan. But if you have a wall that's misaligned, that's off by 10 centimeters, it's not going to try to form a constraint between that. So you can get a great report, but then when you actually look at the data, it can be offset. So there's no way around it. You have to review the data. You have to go through and use some of their QA, QC tools. Register 360 is used with those bundles from the RTC 360, that smaller scanner. So those viz links that it forms can only be dealt with in Register 360. So I'll ingest it into Register 360, do a lot of cloud checks and everything, get a loop in, perhaps apply some control. Another good thing about Register 360 is that you can delete noise in bundles, not from individual scans. So if you've got a series of 20 scans and there's a bunch of smoke in the middle, you can delete it all in one swath. So it's much faster than doing it in Cyclone Core. I really look forward to a future where they've integrated these so you have the strength of both, but they're not there yet. Very far from it. So I'll bring those bundles into Cyclone Core normally. The problem with this, completely not user friendly. Even looking at this interface here, it's ugly and it does a lot of things behind the scenes that it takes you a while to figure out exactly how it works. Documentation isn't good and actually pretty outdated. Despite all this, it is one of the best ones and it's capable of huge registrations. So the biggest database you can put into it is 1 terabyte. That's the limit. But you can also have separate databases and then reference them together. So that helps in data management. You don't want to, have something grow to 1 terabyte because it can crash easily, or if you want to move it or back that up, it's untenable. Not easy to work with. So that's another thing in the office to keep in mind is data management on our side. So all scanners measure the world around you. They don't work in the imaginary grid systems that GPS works in, or any number of reference frames that we're going to have to relate that stuff to. You can do it in the P series. You actually can get it to scale that data. I don't like to do that because it adds another question to it if we work with this in the future. Instead of saying like this point to this point, it's real, then you're going to have that scale distance and you have to deal with that later. Very important prior to doing the field work, even the proposal, is we want to know what reference frame this is in. 10 TM, UTM, 3TM, grid versus ground is going to be their ultimate deliverable. When we register it, we will do so in ground. We can use other software solutions to actually scale the entire point cloud down to grid if need be. It all depends on what they want. The other option is to do any drafting we have to in grid and then scale that down to, in ground, do all our drafting in ground and then scale that down to grid. Yeah, we just have to be aware. Ask the questions, be aware of it before you send the field work out, and just have everybody in the process knowing what the reference frame this is in to avoid any problems. Cool, huh? Wow, that's awesome. So what can we do with it? It can be used for basically as far as your imagination can go. It can solve a lot of problems that are limited by either safety, site access. So if there's a very remote site, a sensitive site, or even with COVID, something where you don't want people visiting, you can go through, collect all the data. You don't have to go back. If you collect it comprehensively enough and do all your control work and referencing work that you need to, now you shouldn't need to go back if you're comprehensive enough. What can you do with that after? You can make a topographic site plan. Of course, in our climate, Weather is a concern. Snow, of course, is going to include things that you will want to include. So be aware of that when you're doing a proposal. You'll want to say that as an exclusion as well. This is intended, snow and ice can obscure. This is valid from this time to this time. Something to keep in mind for that. Monitoring changes, it's not the best direct monitoring solution because, as I said, you're adding air into it. So if you want to know a point on a wall, it's critical that you have a number of observations that a lot of checks to it. It's always better to use either level or a total station. But if you're talking about broad changes in something, if you want to see how the entire face of a wall or building is moving out, rather than having points 10, 15 meters apart, you can make a model and a mesh that illustrates those changes in between. There's a million other ways that you can deal with this. A lot of times you'll be talking with an engineer or something, and they'll have a problem. They'll come to you and say, how can we measure this thing that's above a train track that's active or something along those lines? You can do it without shutting down the train line or putting a person in danger. Yeah, any number of things. A lot of times people are using it for 3D modeling, and that is becoming much more common, and I'll get to that in a moment here. I'll just zoom through since we're getting close to the end of time here. So industry sectors that need it, facilities, that's a big one for us, and I think that's a good area of growth for us too. We work with CNRL. They have an extensive modeling program. They have the entirety of their site modeled and active in a database, so it's kind of a requirement for them. And I would think that a lot of other larger oil and gas facilities, if they're not doing it now, they need to. I worked for Husky in years past. They did not have a program like this, and they're talking about setting it up. So this is a big thing to go with a lot of these providers. Enbridge, Suncor, Keyera, any of these guys we work for, we have done a few scans for them. Just something to keep in mind that we can provide this data cost effective relative to other providers. As we've shown with Horizon, we seem to consistently win the bids there. Real estate is always going to be something that could come up as far as real estate investment trust. They want to have a walkthrough of a building. Architecture, that's an area we want to focus on more because Revit models are becoming very commonplace with that. And Alberta Infrastructure actually has a line in some of their larger project RFP guidelines that BIM is a requirement, and preference will be given to those that do some degree of reality capture. So it's not nearly as hard to sell this as it used to be. Previously, it used to be you have to explain what it is, show it to them, and what you can get out of it. Now people just ask for it, even if they don't know any specifics about it. The other problem is always budget, right? Like, of course, if you're coming at the start saying this is going to be a $15,000 survey, everybody shakes their head because when they're coming up with a budget, that's taking their piece of the pie out of it. But that's becoming less and less because it's getting to be required and people know the value that it has. So if they can sell that on their side, that this area of survey is worth it, it's something to pursue. And yeah, it's becoming easier and easier. So if a client calls you, they want to scan, largely they'll say something along those lines. I'd like a scan. Okay, what type of scan? What are you doing with it? Is it just a point cloud? Are you going to be modeling from it? What coordinate system do you want it's integrated with? And most importantly, do you want it colorized? We're talking a minute per scan for the RTC, one of the quicker solutions. So if you're doing 200 scans, that's already 200 minutes. And then your file sizes in the office will grow by 3 to 4 times, computing time much larger. So if they don't need it, I'll generally drop that. It saves them money, it saves us effort. Everybody's happier in the end. You'll see that kind of reflective file that I showed you earlier. Important things for formats that they ask for. There's 2 types, structured and unstructured. So structured or gridded data is very, very large file size because it includes the location of every single scan and there's no thinning of the data. So that's usually used for modeling programs because a lot of the algorithms they use to detect pipes, walls, and et cetera, they are they rely upon that type of data to detect those walls and pipes. So that can be critical. If they don't need it, give them unstructured because it is vastly smaller and easier for them to work with. As far as a model goes, if they say they want a model, be very, very cautious with this because the time and the scope can become massive. So if they ask for an area and you say, yeah, I'll just do a model, and you don't define a certain level of detail, that can get away from you quite quickly. We don't model in-house generally. We offshore it to India, and pretty much everybody will as well. It's 10 cents on the dollar, so there's no way to compete. It's good to have some familiarity with the models here, which we do. But as far as creating a model, we are going to offshore that. So if somebody asks for an oil and gas facility, model it, and you say, okay, that can turn into trouble because you can be talking about weeks and weeks of effort and tens of thousands of dollars. And a lot of times they don't even need it strictly. If they're just looking for a spatial representation, they want to add on to some piping in a certain area, they need a model for that. And then they're concerned about clashes around it, which the point cloud can serve. So you can kind of manage those expectations. Another big portion is clash detection. They can run a point cloud or a model through a program that's going to check from what the plan was for what's actually built to see if there's clashes. So did a guy putting in fire protection, did he move the pipe over 5 feet because it's a field fit? Did HVAC guy move something over because something else was in the way? Did they actually build an oil and gas facility the way they said on the as-builts? This lets them come up with a whole report for that. And that's growing as well. That's becoming more and more commonplace. Another big term is scan to BIM. This means nothing really. It's quite common, so we have to use those words, but there's no real truth to it. A building information model is so much more than just 3D geometry. The intention is to manage a building from design. So you're putting together what kind of fireboard do we need in this area? It has to be this spec. Then that lets them come up with a bill of materials for someone to estimate to purchase the material after it's all built. Then they'll apply some data to say a heat pump or a furnace or something along those lines, saying this has this life cycle. So it's used to manage a building from start to end for its entire life. Generally, the only part we're going to be involved in is the 3D geometry. So when they say a BIM, if we want scan to BIM, it generally means they're going to want probably a 3D model in Revit format. We can provide that. Normally, we're not going to add the intelligence into it. That would be, the size of pipe, the inner diameter of piping. We'll usually just do what's referred to as level of detail 300, the accurate physical dimensions of the element itself, but not the associated intelligence. So that's something to be aware of, and that's always a conversation to have. We'll see how that grows in the future as far as applying that intelligence, and maybe we move into that a little bit more, but it's a very specific area of expertise that all of these general contractors and architects now have those people in-house, and that's part of their process. Other deliverables, we can give people a true view with a free viewer. So you can zoom around the point cloud. If you look in the bottom right, that's actually the point cloud itself. This is an Enbridge site that we scanned last year. The one on the left is a top-down view. Each one of those circles is the scan location. So if you click that, it's going to zoom into the picture that was taken there, and it's got the point cloud data in behind it. You can pull measurements, you can make markups. This is a free viewer you can give to anybody. So we export the file, we give them the viewer, and they can just look at it. They can give it to whoever they need. Another one that we have here is Cyclone 3DR. We can create a viewer for that too. Similar deal. This is that warehouse I'd mentioned just recently. So what you're seeing there is a colorized floor slab based upon elevation, and then I included the rest of the point cloud in the area around it just for context. So we can give them that. The one on the right you see here, we had worked with Ellis Don doing Center Street Bridge lower deck upgrades here in Calgary. So we had used the scanner to pick up everything all around to give them a design basis for the complex geometry of the arches and the wall faces. And using that data, they designed this screen system, and then we could bring that back into the point cloud to check that it's constructible versus everything around the outside. We're not going to have any clashes or anything like that. So just a couple examples of what can be done with it. Very useful to be able to put that data in their hands. They do have to be a little more tech savvy, but once they actually put hands on, it can be a great sales pitch, because for us, it's just another export. Yeah, moving on to some of the software we use. CloudWorks plugin for AutoCAD or Civil 3D. We can draft directly from the point cloud in AutoCAD. Cyclone Core has a ton of functions in it for modeling, topo, a number of things. Cyclone 3DR does as well. We use that a lot for UAV type stuff. You can classify point clouds in it, and you can create DTMs. That allows us to rapidly do this stuff if we have a good clean scan of the area. Of course, higher vegetation doesn't work as well. Snow or something out there, you're going to have to be aware of that and augment with field survey. Yeah, I was zooming through at the end there just because we have, I guess we're past by 10 minutes here. But yeah, I wanted to open up to any questions if anybody's still sticking around and has some time. I think everybody's ears hurt. Talk too much. My voice hurts, so.
Thanks, Ross.
Sure, no problem. I'll be putting this up on the drive, and I'll share that link. As I said, there's a few links in there to some white papers and stuff that'll, let you dig deeper into some of the data sheets and things like that. So.
Awesome.
All right.
Okay. Thanks a lot, Ross. Really appreciate it.
You bet. Thanks, everybody. Reach out to me if you have any questions or anything. Kind of what I'm here for. So.
Thanks, Ross.
Well done. Thank you.
Thanks, guys.